1, 2, OK. Hi, guys. How are you doing today? Third day. Active or tired? Oh, it suddenly got silence. OK, I'm same mood as you. It's third day. So today, we're going to speak about high-performance systems. And my name is Orkhan. Let me just start it. OK, got it. So I'm working for Global Logic as, consider it something like CTO for Europe region. I'm responsible for a group of architecture and domain experts, a solutioning group, and we usually do sketch architecture solutions for our clients or help them to review their existing solutions and to give something like a future state vision, how we can build it to make it better. And this topic today is actually about a similar thing. When we review some of the applications or solutions, sometimes, I would say most of the times, there's something like performance issue. Otherwise, clients usually pick it as a major attribute. We want performance to be good. So performance is an architecture quality attribute, a quality attribute of the system. And this speech, what's in it for you guys? I structured it in a way so it's too simple. If you're a beginner, newcomer, a junior, you will find something that you really understand, and you can reuse it. If you're a seasoned expert, I'm not going to tell you something new, but what I tried to do to bring it some value, I may be structured in a way that you can use it as a checklist. So today we will be reviewing tactics, principles, patterns, and anti-patterns regarding the performance in different systems, be it something you start from scratch or something that you review an existing application that you want to optimize. But before we start, there will be a quiz provided by Global Logic with some prizes. You can use this link, scan it or photo it, and then attend to that quiz. So there will be also some questions from me regarding to the presentation. So I want to make it so that you have to listen to me attentively. OK, next thing. By the way, if anybody have lost it, just another second chance. And our booth is close to entrance, so you can find us, and we will just give you this QR code again to scan in any case. Architecture. What is about architecture? We usually, how many architects we have actually here? Any architects? OK, I see some hands. How many engineers do we have, developers? Just to understand, OK, a lot of. Do we have any, let's say, Devoxx guys? Any QAs? OK, thanks. Now I understand who we have and how much. Now, when we speak about the architecture, it is usually about quality attributes. Usually just about that. We have 12 classic quality attributes. Each of them can be split into many others, like sub-attributes, or like in a joke, you can add ability to any word and say it's an architecture quality attribute, like, I don't know, medicability, a medical quality architecture quality attribute. So any word, basically. But there are 12 standard ones. And usually how we work, like you know it from books, or maybe you have done it in your life, we pick 3 or 4 major attributes, saying these are priority attributes. And any system designed will have all of these properties, all of them. But you cannot design a system considering everything. So you have to make a judgment, you have to make a prioritization, and usually you pick 3 or 4 out of these. And performance is usually one of the most picked ones, like performance, scalability, sometimes availability, which is under reliability in my list, security. And between some of these, there will be always a trade-off. You know what trade-off is? Anybody don't know what is it? OK, so when you take performance as a priority, you have to lose something else. For example, performance versus security. If security is a priority, sometimes you will lose performance because of security, because you cannot skip it, security, nowadays especially. Now, first thing to remember is that architecture, as most of the development processes, is something iterative. First of all, you cannot optimize something if you don't have it. You're not going to over-architect on the paper. If you do it, you will never go to production. I mean, what to optimize? There is nothing. You have to do first release, at least. Okay, after you do it, you can measure it, have metrics, logs, and see, okay, what's working good or bad, and start to optimize. This is going like in cycles. You cannot do everything in one single sprint. So again, we're speaking about prioritization. What's going to be first, what's next? And then we have to think about risks. It is a development process, and our customers, or we as a product or startup, I mean, we don't want that code. Have you been in that situation, like your friend is coding, you're asking him, when is the release? And he says, it's my startup. I'm already doing it for 3 years. Okay, when is your release? Next 1 year. After a year, he says, okay, I'm still doing it. And you say, okay, when do you going to release it? And he says, look how cool my code looks like. It is so beautiful. I mean, so what? When do you going to release it? At some point in time, you have to release it. So you got to work with risks. And the architecture team, or you as an engineer, DevOps, or somebody else, or QA even, if you are going to work with the architecture of the system, you have to make a decision, okay, what risks we have, what are we going to skip, in which priorities we are staying, and this sprint we do this release we do this. Next things later. So what are your risks? What you can lose if you don't do some things now? Once you are thinking about it, writing them down, having some mitigation plan. Next. Design, document, documentation. I mean, how much do you document, really? Do you write 100 pages documents? Usually no. But the problem is that any documentation is a documentation. If you have nothing, what is not documented, it doesn't exist. I mean, when I go into a new project and I want to read the code, there are like thousands, hundreds of thousands lines of code. I'm not going to read it all. Eventually it will compile, but how should I learn it? Read comments? It's good for developers, but working on some classes, on some files. But for the architect or a tech lead, you have to have a documentation where I can look and get a quick summary as an onboarding. If it's not documented, it doesn't exist. Once you have all of this done, now we start to analyze each quality attribute. Today, just performance. What is performance? Many things. It can be latency in milliseconds. It can be, I like the word budget, pre-last one, because it's not about money. Budget is latency budget. For example, you have a real-time system where between microservices, in a row of microservices, you can only have, in a near real-time system, only 25 milliseconds for latency. You cannot do it more, and you need to do it like lower than 20 milliseconds for response, because we guarantee our clients near real-time performance that all requests will be handled under 5 seconds, almost real-time. How you can do it? You have a latency budget. Each microservice should be almost real-time, answering your questions, API calls, only within 25 milliseconds, for example. Or a memory budget, how much memory we can use, or throughput, or anything. So performance is about measuring and working within some limitations. Next, you will always have a trade-off. We already talked about it. Just a quick example. There are 2 architecture patterns. One is called triple, or sometimes if you Google it, N modular redundancy, and recovery blocks. One is about performance, another one is about reliability. When you do modular redundancy, what means? You can skip any resources. You want to get a quick response. You need a responsive performance system. What you do? I can put my backend service in 3 copies, or 5 copies, or 10 copies. I don't care about resources, horizontal scalability in its maximum, and I don't care about how memory, how many virtual machines are used. Just don't care. I need fast. I need correct. What I do? When you trigger shut a API request, for example, it goes to all blocks. They all do same work, and whoever was first with the correct answer, the water gets it and returns back. All waits for all resources, all responses, and gets back. In one case, you have performance, get the first one correct. In the second case, get all responses, make it more reliable. but you are using a lot of resources. In recovery blocks, what you do? We want the system to be reliable as in previous case. Like, I can wait for all resources, but it's not performant. It uses a lot of resources. Instead of that, I say, OK, I split system into 3 blocks. First block has almost no exceptional cases to work with. If there is an error, it's gone. Shit happens, OK. But it works fast. There is no additional code. What happens? You trigger the call, it just shuts it, and you got fast, quick, dirty result. If you think that result is wrong, now 80% of users will get this result, and they are happy fast. 20% of results, which are wrong, abstractly, handle it to block 1. It has a little bit more logic to understand what happened, what was the error or exception, and maybe to handle it. If it does it, return the response. If not, send to second block, which has a little bit more code, more time to think about. And you see, like, we are prioritizing performance in the second case over reliability. This is a trade-off. Which one will you pick for your current system? Now, one ask to you guys. Think about your current project, where you are working. At your work, your startup, pet project, anything. Now, the rest of the presentation, everything we will speak about, try to think, can you apply it to your project as a principle? Let's start with tactics. What are the tactics for performance? Very easy. Have this screenshot from the book. You have the book name there. You can copy that. First, resource demand. Well, a good example, vertical scalability. You need more resources. You need more and more, and you just threw in more resources, and it works that way. Resource management. You are going more smart. A good example, horizontal scalability. You need more resources, but you don't throw in like vertical scaling. You more do, OK, I can share it, shard it, split it, and so on. Partition it. And then third one, resource arbitration, cron. Time. Split performance by time. The book says, the software architecture in practice, it says like second edition, just a note, if somebody will ever read this book, there is a third or fourth edition, more modern one. And resource arbitration, the time, cron example, is actually merged to the previous bucket, to resource management. It is actually. But I'm an old school guy, and I like this version more because it's more structured for me. Like vertical, horizontal, and time-wise. But vertical, horizontal is not the best example. It is just a good example, but a simple one. So resource demand, management, arbitration. Now, based on these tactics, how we can work, based on which principles? There are some principles you have to follow, or you may follow, you may not. But it helps me when I review a system, and it's usually a checklist. Just get a Word document, one-pager, with all these checklists, and just 1, 2, 3, 4, OK, check, 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 not check, and we fix it. What are these principles? First of all, instrumentation principle. A good example, logging. You have to instrument your system with some piece of code that can give you access to see what's happening inside. Logging is a good example, but not the only one. We're using it automatically. But logging is just one technique. It is a basic principle which says, write some code that will give you access to inside of your system, even in a live production environment or somewhere else. And to make it an instrument based on this principle, it should have a toggle on, off. Or maybe even some different operation modes, like logging, trace logging, or debug logging, and so on. Logging is a good example, but think about what other instrumentation you can build into your current project that will help you to see more performance issues. Because logging is a slow thing. You have to read these logs, find it. Or maybe you have a hardware system, then OK, it will be even harder to see it. What you can do there to get signals out faster. Synergy principles. How different components will work together. So usually it's about 3 things. First, resource sharing. You always think, how can I share resources in a way, in a way so that any blocked resource is not blocked for a long time. Not all systems can be built in a non-blocking fashion. I know like backend guys here will tell like non-blocking front-end guys will tell no blocking, some hardware guys will tell we have non-blocking APIs, but I mean, it's not always possible. There are systems that are blocking. They have locks. You have to deal with it, no other options. You have to minimize these windows. Resources are limited, but you can control it. The other case is parallel processing. Real parallel, not real parallel, it doesn't matter. We all are using threads and similar things in different systems we use, but when you use parallel processing, the justification for an architect is very simple. When it really works. If overhead over the communication to coordinate these system resources for multi-threading or for parallelism is over the performance gain, don't do parallelism. Just because it works and just because it's beautiful, it doesn't mean you have to use it. Then, and by the way, measuring. Performance is just about measuring. So simple. No, there is no, let me use the right word, there is no creativeness in it. You may have a creative solution, but measuring, it's just something 1 + 1 is 2. You just have to do it. A load sharing principle, it's more about the time, again. Divide resources. If you have a reporting generation tool and you, like, user clicks the button, you generate report, but then if a high-load system, why you need to do this? Are these reports really real-time? If it's a report like today for yesterday or today for today, maybe I can do it in the nighttime. Okay, you, tell your user, got your request, tomorrow in the morning you will have a report in your mailbox. Very simple thing, we all do it. But sometimes when we look to a system from design point of view, we don't usually think about it. We just get the truth like, code is written this way, and we need to optimize it, but we don't have resources. Come on, use these principles and you will have something there. Anyway, independence of different components. The principle, set of principles about how different system components can be independent. And this one gets a little bit interesting now. There are a few things here that I really love. In the very early days, when I was a developer and was transitioning, learning to be an architect, these things actually helped me to understand it. It's not something new, but you look to a system from a different perspective. First of all, centering principle. You don't have to optimize everything. Don't overdo it. Don't over-optimize. Don't over-architect. Remember, it is an iterative process in sprints. You don't have to optimize everything. You need to pick dominant functions. After you're measuring, 20% or so of the system, I'm just using Pareto rule, like 20 to 80. 20% of system functions are making the 80% of load impact. And in each sprint, there will be some 20% that you can optimize. Forget about everything else. What are the dominant functions for this current iteration, this sprint, that we need to optimize? Measure, count what you can do, give the solution, and concentrate on that. Fixing point. Once you understand what are the dominant functions, now, in every system, backend, frontend, hardware, infrastructure, in all systems, there is a moment, time, when a request is reached to the controller. Backend side, hardware, anything that gets this request and does something, even on UI, on web pages, everywhere. The fixing point principle says that the time when you do this fixing, when requests are calculated and reached there, it should be at the very end. For example, an ATM. Everybody has a bank card. You are using ATM, withdrawing money, is it? Anybody without a banking card nowadays? I heard it. Yeah, so when you go to that ATM for withdrawing a cash, what do? You input your card, you do like PIN code, you pick the amount. Everything is done offline. There is no fixing point. Just at the very end, when you say approve, it connects to the server side and gives you the money. This is the fixing point. If you have a lot of connection points, optimize it. For example, by the way, example for microservices or backend systems will be an API gateway. Don't do like a lot of requests to the backend. At the external one API gateway or something like that, call it experience microservice or so, do one request there, and it does all internal requests. But I've seen UIs that do like 6 requests to backend to load one single web page. It's not optimal. It's not a performance thing. Locality. I think you know it. Just very standard thing. But we usually forget about it when we review systems. So this presentation is about what not to forget. Just a checklist. Locality can be different. A good example for that in big data systems, when you receive some processing request, what you have to do is where this information will be processed. You don't want to collect all the data, gigabytes, terabytes, from all these servers to one place to handle it. You just split it, like MapReduce or similar systems. You split it to different computers, tell that every piece of data is handled on the same computer where it's done. And locality can be different, by memory, by network, by time, so just the locality. Process the resource maximum closer to the place where it really exists. And processing power versus frequency. There is always a trade-off here as well. We usually do systems like, OK, I have these resources, and I just do it, and it works. But think about in your current solution, your application that you write, develop, or design now. Is there any place in your system where you can make a judgment? Do I have to process a big chunk of work once, or I can split it so that I will process a lot of times many smaller things? We usually don't think about it. We just code it and it works. But embedded developers, hardware close, like limited hardware kind of developers, they think about it. They have very limited memory, very limited CPU. So do you want to process a lot of things, or your users can wait, clients, and you want to process one big thing? And once you finish all these principles, like understanding, OK, what I can use, now we're thinking about patterns and anti-patterns. What patterns to apply? It's a quick list. The very basic one is FastPass. Do you remember my example with ATM, cash withdrawal? Any ATM has this pattern already inside. There is a path, usually, when I do standard things, just code it, all the logic behind that. But performance is not only about the logic. What says FastPass? Performance can be also about physical system. Like, for example, people are waiting on the waiting line in front of ATM. It is not a performant system because people are waiting in a longer waiting lines. What ATM developers did? Banks decided, OK, we will introduce a FastPass. You do all the operations, but then there is a screen saying how much money you want to withdraw, and there is standard numbers. You remember, like 5, 12, 100, 200. This is the FastPass. If you do it, you don't have to input 200 enter. Why? You can do just one click and that's it. In any system, in any kind of system, you can have a FastPass where you skip all unnecessary work, serve for 20–30% of your maximum power users that can have this performance quickly, or 80%. Usually it's most of users, they don't need all operations. In some cases, when a user wants some custom operations, like 20–30% of your users, the smaller amount, they can click a button and go into custom and customize things. This is the FastPass. How much do you apply it in your systems? Think about where you can apply it. First things first, it's more about on what we do concentrate. We already spoke about dominant functions, similar things, but what first things first says? The pattern says, for example, radar systems. In a radar system, it's an embedded hardware, and there is a limit for memory for processing. For example, I'm not a radar expert, but I know that it works like this. You have a radar. It has a limitation. For example, let's say a small radar with 100 objects it can show, not more. If radar catches everything around, it can show you cars, big trucks, helicopters, airplanes. Once you have 100 objects there, you may not notice something that flies right to you. What you do? You optimize. I don't want to see cars. How can I filter them? I don't want to see helicopters. How can I filter? So all your sensors are filtered in a way that they catch only those items that are necessary. And this is also performance. Now your radar shows only 40, 50 items, and it means that it has still capability and capacity to show more if needed. Not only radar systems, but what you can do in your system where you can concentrate. So you see, it's all about concentrating on dominant things. Batching, very simple thing, but do you use batching in your system? Anybody who is using batching? Not so many hands, but yeah, I see. So a good example of like messaging. Some time ago, a friend of mine was developing a messaging application, and all messages were sent. I said, why you don't do batching? He says, why? It works. But if you scale it to 100,000, thousands, or million users, okay, batching can save your life. Because, for example, if you add there a secure messaging thing, like you emphasize security, what happens? Each message is encrypted. It gets your phones or tablets resources for that, for encrypting. And security is kind of, yeah, it uses a lot of resources. How you can do, introduce a window, don't encrypt every message. If I write messages fast, wait for 1 or 2 seconds before sending. You remember previous pattern, the fixing point, no, principle, fixing point principle. Wait, wait, wait. If user has stopped the input, batch it, encrypt once, and send. Think about, in your system, where you can use it. Alternate routes, it's more about the older days. I like the example with databases when we had like multi-dispatcher databases. Like a database is capable to do anything in your system, but like to serve all users. Or instead of database, your microservice or anything. It is a very big server, capable one. It handles all users. But the problem is that network channel is not enough for the amount of data which is passed back and forth. What you can do, add more networks, add more dispatchers that lead to the same backend. Backend is capable, but you just need more throughput. An example also regarding the infrastructure part of that, sometimes. It's not an issue in modern days, but there are cases like this which you can use over different solutions. Flex time, report generation. I already did it. I already talked about it. So like, if you're looking for a performance optimization, can you fix it in a way by just sharding things to time? Not by click or by user action, just schedule it. And you win some time. You can do it in night hour when we are sleeping but servers are working. Slender cycling functions is a pattern which says that we can also split system to smaller chunks, functions that are actually doing work in cycle. It is a good way actually to switch from here to anti-patterns, because you can have a small function which works like 30 seconds, and you say, okay, every 1 minute I am triggering it. It's more about, we had some system developed. We have some 6 or 12 months has already optimized it to some point. But 1 year passed, 2 years passed, now you're working in a project which has some history behind it. Not everybody is from the very first day here. Some people left, some people new, onboarded. What happens? A function that was like 30 seconds of execution time, and it has a 1 minute window so that system can rest, got bigger. There were fixes, there were some additional logic implemented, and functions started to work 1 minute, 20 seconds. So tail of previous function is here. It's not finished yet, but we are already starting new function. So you see, it's about measuring the system, seeing some instrumentation like logging or other examples. And if you don't do it, this pattern, which says that you can do it in cycles, actually will become an anti-pattern, because you didn't watch for that. And here we switch to anti-patterns. Anti-patterns are very, very simple, but I still, in 2023, I still see people who are doing same just errors, same fails, same things, like God class or God microservice. Who is developing microservices here? Okay, guys, just a quick question. Do you develop microservices APIs thinking about what they should be granular and not do it? Or you develop like, okay, I will add here another API endpoint just to make it work, because why to develop new? Whoever does it, like, just add it here, let it work. Okay, I don't see hands. You are shy or you really do it right, but we do it most of the time. So if you look to most of the systems, front-end part, back-end, data tiers, databases, data platforms, infrastructure, everywhere there is an example of that, like, okay, I'm doing it this way and then do it this way, but I just need to do it this way. analyze it. Then once you have all the systems split correctly, granular APIs and similar things. Now, dynamic allocations. We usually don't speak a lot about pooling objects because it's just a normal thing. We usually have standard like database connection pools, other pools, and so on. But can you use pooling mechanism for something in your system? For example, a mobile application that gives calls. I've seen an application that just every time creates a new call object. Why? When I call, I don't need to create. How many times you can call here? I mean, a call is one just call object, one call, nothing more than that. I may have like join other participants, 5 or 4, but it is not like 30 people on the same call with new call and some parameters. Call object in a phone can be a pooled object. If you are using a custom API which you are developing, for some other tasks, how many pooling do you have? Usually, if not, then it may be an anti-pattern. Circuitous treasure hunt is my beloved one. Usually, as example, web systems, I used it today, a UI which sends a request to server to get some part of that, to get some part of information, to generate next request, send it there again, and you still don't see UI. To receive next part, generate new request, send third one, and do it 6 times to show only one single web page. Come on, really, add one single service at the back end, do one request, it will collect all the information and send it back to you. It sounds obvious, it sounds simple, but how many these kind of issues do you have in your systems, guys? I'm seeing it almost every 1 or 2 months. And just going faster here, the one-lane bridge, which is more about bottlenecks. No, it's not even a bottleneck. Sometimes some locking APIs. By the way, a good example. A car manufacturer had a problem that customer in Europe, just keeping confidential but confidential, sorry, cannot tell everything, but a customer in Europe called the car company saying, I bought a new car from you with a Wi-Fi, but every time it rains, Wi-Fi stops working. Customer support said, like, okay, restart your car. And it really worked. After a week, this guy again calls, and it's a real situation. I've been there in like 9 or 8 years ago. Then he calls again. When it rains, my Wi-Fi stops working. Okay, did you restart your car? Yes. Does it work now? Yes, thank you. It happens like a few weeks during the winter time, and then at some point, customer care thinks like, okay, a lot of problems, and let's send it to real support who can think about what may be there a problem. But it is just one user over the whole country for the new car. And you know what? The problem was that Wi-Fi system creates a log file. I don't know why, just creates a log file, something.log. And when it rains, the thing that cleans your window, it also creates a log file. And accidentally, the name of this log file was same. But hardware system have more priority over the Wi-Fi. And Wi-Fi stops working because it cannot control the new log file. When you restart the system, it's just restarted. That was like, shit happens. Accidentally, 2 different teams creates one log file with the same name, and just because of the priority, it doesn't work. It's a one-lane bridge. If one is crossing, another one cannot do anything. You can actually skip these problems if you do better planning, thinking, okay, where there can be a problem. If I am creating a log, it is potentially this one anti-pattern. If I'm creating a log, what I should do? Document it. Announce to everyone. Discuss it with everyone. Keep it in the documentation. Like, if anybody in any other team in our company creates a log file, first look to the documentation if there is something with the same name. And you will never have this problem. And all other users really didn't tell anything to customer care because, I mean, Wi-Fi stopped working. I don't care. I have a mobile phone with LTE in that, and well, it was 3G that years, back like 9 years, 7, 8 years ago, and everybody like didn't care about it. But it was just one guy calling to customer support, like, why it doesn't work? I paid for this. And the traffic jam, very simple one. Anybody doing multi-threading applications? Okay, great, you know it. Like if you have a lot of threads of high priority, then sometimes it can be so much that lower priority threads will never execute or execute very slow. And usually we don't see these problems before we reach them. And then you have to do bug fixes. But at the architecture engineering level, you can actually review a system. Think about, okay, if we're working with priorities or some other any example in your current system, then we need to measure it. What you can do not to have this problem, put an instrumentation kind of piece of code which will actually measure it, and if there is something, will alert you that some of lower priority things are not executed or are executed during longer times, and it can alert you, and you can have an instrument inside to change these priorities or so, and you don't have to even like deal with it as a bug request. It is just a optimization next sprint. That's it. So I'm stopping on this. We have still 14 minutes for any questions. I know it was a simple one. I hope it was a good checklist that you can use. And you can find me on our booth. If you scan it, there will be a map with small green point there. I will be there for next couple of hours. You can find me here or there, and let's discuss it. My contacts on LinkedIn, if you would like to keep in touch and discuss maybe a little bit more difficult, complex stuff. And thank you very much.